Okay, for section 4.4, you missed the lesson, so it's a little tricky. I'm going to refer to this chart. We're doing graph transformations, and what I'm doing is I'm starting with the parent function, y equals x squared, just the basic parabola. All quadratic equations are versions of y equals x squared, and that's this pink graph right here. And these points, 1, 1, 2, 4, and 0, 0, are on the graph of y equals x squared. So let's see what happens, how the graph changes when I change f of x. So the thing to remember is that if we're changing the input x, we kind of have to think counterintuitively and do the opposite of what you're seeing done in the brackets. If we're changing the y coordinate, then we do things intuitively. We do it exactly like it says. So let's take a look at what I mean by this. So for this example, we're not changing x, the input x stays x, but we're changing something outside the brackets. So we're actually changing the y coordinate then. And that means I'm going to do what it says. I'm changing the y coordinate. So it looks like the y coordinates all go up 2. That's exactly what happens. The same x coordinates in the function g of x equals x squared plus 2, which is this equation, will result in y coordinates that are 2 more than they were before. So 0, 0 in y equals x squared becomes 0, comma 2 in f of x plus 2. So everything shifts up 2 units because the y coordinate is our up-down shift. It tells us whether things are moving up or down. So that moves things vertically. So it moved up vertically 2 units. In this example, I'm changing something inside the brackets, the x coordinate. So this is where I think counterintuitively. So that x, changing x by the way, changes it to go left or right. You would think that I would move it ahead 2 units because you see x plus 2, but it actually goes counterintuitive to what you think. It's going to move left 2 units. Replacing x with x plus 2 gives me a new function, x plus 2 quantity squared instead of x squared. And in this function, I have to throw negative 2 into the parenthesis for x to give me 0. 0 squared will give me 0. So on this function, y equals x squared, when x was 0, y was 0. But in this new equation, this transformed equation, when x is negative 2, y is 0. That has the effect of shifting everything back 2 units. On this example, I'm not changing anything inside the brackets, so I'm changing the y coordinate. And instead of adding 2 this time, I'm going to multiply each y coordinate, or each f of x value, by 2. So the same x coordinates I had before, 1 and 2, will not yield 1 squared and 2 squared, 1 and 4. Now it's going to give me 2 times 1 squared and 2 times 2 squared. 2 squared is 4, multiplied by 2, I get 8. So every xy on the graph of y equals x squared is now x comma 2y on the graph of 2f of x. Y equals 2f of x. So what this does is it stretches the graph out vertically. All the y coordinates are twice as much as they were, so everything gets pulled up 2 units. It's not translated up. The vertex stays the same. 0, 0 is still 0, 0 in this function too, because 0 squared is 0 and 0 times 2 is still 0. So it's not pulling up like a slide up. It's pulling up like a stretch up. In example 4, we are changing the input x. So we're changing something inside the brackets. So think counterintuitively. So that means that every x coordinate, instead of getting doubled, is actually going to get cut in half. So for number 4, here's the parent function, y equals x squared. Now it becomes y equals 2x in parentheses squared. I'm changing the input from x to 2x. And if you do 2x times 2x, you actually get y equals 4x squared. So I'm leaving the y coordinates exactly like they were before, but now my inputs have to change to get out these y coordinates. Before, in this function, y equals x squared, I had to plug in 1 to get out 1. 1 squared equals 1. But in this new equation, 2x quantity squared, I'm going to have to plug in 1/2 for x to get 1 out for y, because 2 times 1/2 is 1, and then 1 squared would give me 1. So it changes the x coordinate. So what that does is every x coordinate is cut in half, but the y coordinates stay the same. And so if every x coordinate is half of what it used to be, changing the x changes it horizontally, and all those x coordinates are half what they used to be. It has the effect of shrinking it horizontally, pulling it in. And shrinking horizontally almost looks like you're doing the same thing as stretching vertically. The only difference is stretching vertically is changing the y coordinate, and shrinking it or compacting it horizontally is changing the x coordinate. So they may look like they have the same effect, but it's two different things going on. For example 5, again, we're changing the x coordinate, so I'm going to think counterintuitively to what I see. Instead of cutting each x coordinate in half, I'm actually going to double each x coordinate and keep the y coordinates the same. And that's how the graph is transformed. So if I double each x coordinate and keep the y coordinates the same on the graph of y equals x squared, this is y equals x squared points, and these are the new function, y equals 1/2 x quantity squared. What that really does is make the x coordinates twice what they were before. So everything gets pulled out horizontally or stretched horizontally. Now it's wider than it used to be. So looking at the homework, this is your graph of y equals f of x. We don't know what the equation is, and I purposely didn't give you an equation. I just want you to think of what's going on here. Over here I can see I'm changing the x coordinate. I'm changing things inside the parentheses or inside the brackets. So I want to think counterintuitively. I'm changing the x coordinate. So kind of think of doing the opposite of what you'd think. Instead of shifting all the x coordinates, x's left and right, and it looks like you might shift it right 2, it's actually going to move everything back 2 units. So for this particular problem, I want to shift this graph back 2 units. The y coordinates stay exactly the same, so the range of this function is going to be the same as the range of this function. And just to give you a heads up on the domain for this function is I have x's in between -4 and +4, so I would write an inequality. It goes from -4 to +4 for the domain. And the range of the y coordinates, so that starts at like -3 and goes up to +4 is the highest y coordinate. So my range would be y is in between -3 and 4. I can write -3 is less than or equal to y, which is less than or equal to 4. And when we make this graph, it's going to change the domain because I'm changing the x's. So the x's are the domain. The range will stay the same. This one, again, think counterintuitively because I'm changing inside the parentheses. For this particular problem, I'm changing not inside the parentheses, but outside the parentheses. That means that I am changing the y coordinate. So do exactly what it says. Every y coordinate will now be 2 less than what it was. So that shifts down 2 units. And on this one, I'm not changing the input x. I'm changing outside the brackets. So instead of subtracting 2 from every y coordinate like I was over here I'm multiplying each y coordinate by 2. So this is going to stretch it vertically. These problems, you have to think about whether you're doing something in the parentheses or outside the parentheses and do the inverse of what you think. This is the same graph as this one on the back side. You just have to, I just drew it again so you wouldn't have to keep flipping the paper over. And I want you to think about these two. I didn't give too much information. This is quite challenging. This is a little definitely challenging. This one you've seen before, right? All the y coordinates are now the absolute value of what they were before. Doesn't change the input x though. So I want you to think about what you're doing with these equations, with the functions, and hopefully that helped.